ideas of Copernicus. Kepler relished this urbane, scholarly community. Here, his genius was recognized at last. Kepler was not to be ordained after Tübingen. Instead, to his great surprise, he found himself summoned to Graz in Austria to become a teacher of high school mathematics. Kepler was not a very good teacher. The first year in Graz's mathematics class had only a handful of students. The second year, none. He mumbled, he digressed, he was at times utterly incomprehensible. He was distracted by an incessant clamor of speculations and associations that ran through his head. And one pleasant summer afternoon, with his students longing for the end of the lecture, he was visited by a revelation that was to alter radically the future course of astronomy and the world. There were only 6 planets known in his time: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. For some time, Kepler had been wondering, why only 6 planets? Why not 20 planets or 100? And why this particular spacing between their orbits? No one had ever asked such questions before. In the course of a lecture on astrology, Kepler inscribed within the circle of the zodiac a triangle with 3 equal sides. He then noticed, quite by accident, that a smaller circle inscribed within the triangle bore the same relationship to the outer circle as did the orbit of Jupiter to the orbit of Saturn. Could a similar geometry relate the orbits of the other planets? Now Kepler remembered the perfect solids of Pythagoras. Of all the possible 3-dimensional shapes, there were 5, and only 5, whose sides were regular polygons. He believed that the 2 numbers were connected, that the reason there were only 6 planets was that there were only 5 regular solids. In these perfect solids, nested one within the other, he believed he had discovered the invisible supports for the spheres of the 6 planets. And this connection between geometry and astronomy could, he thought, admit only one explanation: the hand of God, mathematician. The intense pleasure I received from this discovery can never be told in words, he said. Now I no longer became weary at work. Days and nights I passed in mathematical labors until I could see whether my hypothesis would agree with the orbits of Copernicus or if my joy would vanish into thin air. But no matter how hard he tried, the perfect solids and the planetary orbits did not agree with each other very well. Why didn't it work? Because unfortunately, it was wrong. The true orbital sizes of the planets, we now know, have absolutely nothing to do with the 5 perfect solids, as the later discovery of Uranus, Neptune, and Pluto shows. But Kepler spent the rest of his life pursuing this geometrical phantasm. He couldn't abandon it, and he couldn't make it work. His frustration must have been enormous. Finally, he decided that it must be the long-accepted planetary observations that were inaccurate, and not his model of the nested solids. There was only one man in the world who had access to more precise observations. That man was Tycho Brahe, who, as chance would have it, had recently written Kepler to come and join him. Kepler was reluctant at first, but he had no choice. In 1598, a wave of oppression enveloped Graz. It was spearheaded by the local archduke, who vowed to restore the Catholic faith to the province and, in his own words, would rather make a desert of the country than rule over heretics. Kepler's school was closed. People were forbidden to worship or to sing hymns or to own books of a heretical nature. Those who refused to embrace Catholicism were fined 10% of their assets and exiled from the country on pain of death. Kepler chose exile. Hypocrisy I have never learned. I am in earnest about faith. I do not play with it. For Kepler, it was only the first in a series of exiles forced upon him by religious fanatics. Now he decided to accept Tycho Brahe's open invitation. Brahe, a wealthy Danish nobleman, lived in great splendor and had recently been appointed imperial mathematician at Prague. Kepler left Graz with his wife and stepdaughter and set out on the difficult journey. Kepler's wife was not a happy woman. She was chronically ill and had recently lost 2 young children. The marriage itself was no comfort. She had no understanding of her husband's work and regarded his profession with contempt. Kepler was married to his work, and every tedious mile was bringing him closer to the great Tycho Brahe, whose observations, he devoutly hoped, would confirm his theory. Kepler envisioned Tycho's domain as a sanctuary from the evils of the time. He aspired to be a worthy colleague to the illustrious Tycho, who for 35 years had been immersed in exact measurements of a clockwork universe, ordered and precise. But Tycho's court was not at all what Kepler had expected. Tycho himself was a flamboyant figure, adorned with a gold nose. The original had been lost in a student duel fought over who is the superior mathematician. And he maintained a circus-like entourage of assistants, distant relatives, and assorted hangers-on. Kepler had no use for the endless revelry. He was impatient to see Tycho's data, but Tycho would give him only a few scraps at a time. Tycho, he said, gave me no opportunity to share in his studies. He would only, in the course of a meal and in between other matters, mention, as if in passing, today the figure of the apogee of one planet, tomorrow the nodes of another. Kepler was ill-suited for such games, and the general climate of intrigue offended his sense of propriety. Their cruel mockery of the pious and scholarly Kepler depressed and saddened him. My opinion of Tycho is this. He's superlatively rich, but knows not how to make proper use of it. Tycho possesses the best observations. He also has collaborators. He lacks only the architect who would put all this to use. Tycho was unable to turn his observations into a coherent theory of the solar system. He knew he needed the brilliant Kepler's help. But simply to hand over his life's work to a potential rival, that was unthinkable. Tycho was the greatest observational genius of the age, and Kepler the greatest theoretician. Either man alone could not achieve the synthesis which both felt was now possible. The birth of modern science, which is the fusion of observation and theory, teetered on the precipice of their mutual distrust. The two repeatedly quarreled and were reconciled, until, a few months later, Tycho died of his habitual overindulgence in food and wine. Kepler wrote to a friend, on the last night of Tycho's gentle delirium, he repeated over and over again these words, like someone composing a poem. Let me not seem to have lived in vain. Let me not seem to have lived in vain. And he did not. Eventually, after Tycho's death, Kepler contrived to extract the observations from Tycho's reluctant family, observations of the apparent motion of Mars through the constellations obtained over a period of many years. The data from the last few decades before the invention of the telescope were by far the most precise ever obtained up to that time. Kepler worked with a kind of passionate intensity to understand Tycho's observations. What real motions of the Earth and Mars about the Sun could explain to the precision of measurement the apparent motion as seen from the Earth of Mars in the sky. And why Mars? Because Tycho had told Kepler that the apparent motion of Mars was the most difficult to reconcile with a circular orbit. After years of calculation, he believed that he had found the correct values for a Martian circular orbit which matched 10 of Tycho Brahe's observations within 2 minutes of arc. Now, there are 60 minutes of arc in an angular degree, and of course, 90 degrees from horizon to zenith. So a few minutes of arc is a very small quantity to measure, especially without a telescope. But Kepler's ecstasy of discovery soon crumbled into gloom, because 2 further observations by Tycho were inconsistent with his orbit by as much as 8 minutes of arc. Kepler wrote, "If I had believed that we could ignore these 8 minutes, I would have patched up my hypothesis accordingly. But since it was not permissible to ignore them, those 8 minutes pointed the road to a complete reformation of astronomy." The difference between a circular orbit and the true orbit of Mars could be distinguished only by precise measurement and by a courageous acceptance of the facts. Kepler was profoundly annoyed at having to abandon a circular orbit. It shook his faith in God as the maker of a perfect celestial geometry. Having cleaned the stable of astronomy of circles and spirals, he said, he was left with only a single cartful of dung. He tried various oval-like curves, calculated away, made some arithmetical mistakes, which caused him, in fact, to reject the correct answer, and months later, in some desperation, tried the formula for the first time for an ellipse. The ellipse matched the observations of Tycho beautifully. In such an orbit, the sun is not at the center, but is offset. It's at one focus of the ellipse. When a given planet is at the far point in its orbit from the sun, it goes more slowly. As it approaches the near point, it speeds up. Such motion is why we describe the planets as forever falling towards the sun, but never reaching it. Kepler's first law of planetary motion is simply this: a planet moves in an ellipse with the sun at one focus. As the planet moves along its orbit, it sweeps out, in a given period of time, an imaginary wedge-shaped area. When the planet is far from the sun, the area is long and thin. When the planet is close to the sun, the area is short and squat. Although the shapes of these wedges are different, Kepler found that their areas are exactly the same. This provided a precise mathematical description of how a planet changes its speed in relation to its distance from the sun. Now, for the first time, astronomers could predict exactly where a planet would be in accordance with a simple and invariable law. Kepler's second law is this: a planet sweeps out equal areas in equal times. Kepler's first two laws of planetary motion may seem a little remote and abstract. All right, planets move in ellipses and they sweep out equal areas in equal times. So what? It's not as easy to grasp as circular motion. We might have a tendency to dismiss it, to say it's a mere mathematical tinkering, something removed from everyday life. But these are the laws our planet itself obeys as we, glued by gravity to the surface of the Earth, hurtle through space. We move in accord with laws of nature, which Kepler first discovered. When we send spacecraft to the planets, when we observe double stars, when we examine the motion of distant galaxies, we find that all over the universe, Kepler's laws are obeyed. Many years later, Kepler came upon his third and last law of planetary motion, a law which relates the motion of the various planets to each other, which lays out correctly the clockwork of the solar system. He discovered a simple mathematical relationship between the size of a planet's orbit and the average speed at which it travels around the sun. This confirmed his long-held belief that there must be a force in the sun that drives the planets, a force stronger for the inner fast-moving planets and weaker for the outer slow-moving planets. Isaac Newton later identified that force as gravity, answering at last the fundamental question: what makes the planets go? Kepler's third, or harmonic law, states that the squares of the periods of the planets, the time for them to make one orbit, are proportional to the cubes, the third power, of their average distances from the sun. So the further away a planet is from the sun, the slower it moves, but according to a precise mathematical law. Kepler was the first person in the history of the human species to understand correctly and quantitatively how the planets move, how the solar system works. The man who sought harmony in the cosmos was fated to live at a time of exceptional discord on Earth. Exactly 8 days after Kepler's discovery of his third law, there occurred in Prague an incident that unleashed the devastating 30 Years' War. The war's convulsions shattered the lives of millions of people. Kepler lost his wife and young son to an epidemic spread by the soldiery. His royal patron was deposed, and he was excommunicated from the Lutheran Church for his uncompromising independence on questions of belief. He was a refugee once again. The conflict, portrayed on both sides as a holy war, was more an exploitation of religious bigotry by those hungry for land and power. This war introduced organized pillage to keep armies in the field. The brutalized population of Europe stood by helpless as their plowshares and pruning hooks were literally beaten into swords and spears. Rumor and paranoia swept through the countryside, enveloping especially the powerless. Among the many scapegoats chosen were elderly women living alone who were charged with witchcraft. Kepler's mother was taken away in the middle of the night in a laundry chest. It took Kepler 6 years of unremitting effort to save her life. In Kepler's little hometown, about 3 women were arrested, tortured, and killed as witches every year between 1615 and 1629. And Katerina Kepler was a cantankerous old woman. She engaged in disputes which annoyed the local nobility, and she sold drugs. Poor Kepler thought that he himself had contributed inadvertently to his mother's arrest. It came about because he had written one of the first works of science fiction. It was intended to explain and popularize science and was called The Somnium, the Dream. He imagined a journey to the moon with the space travelers standing on the lunar surface, looking up to see, rotating slowly above them, the lovely planet Earth. Part of the basis for the charge of witchcraft was that, in his dream, Kepler used his mother's spells to leave the Earth. But he really believed that one day human beings would launch celestial ships with sails adapted to the breezes of heaven, filled with explorers who, he said, would not fear the vastness of space. He speculated on the mountains, valleys, craters, climate, and possible inhabitants of the moon. Before Kepler, astronomy had little connection with physical reality. But with Kepler came the idea that a physical force moves the planets in their orbits. He was the first to combine a bold imagination with precise measurements to step out into the cosmos. It changed everything. This fusion of facts with dreams opened the way to the stars. As a boy, Kepler had been captured by a vision of cosmic splendor, a harmony of the worlds, which he sought so tirelessly all his life. Harmony in this world eluded him. His 3 laws of planetary motion represent, we now know, a real harmony of the worlds. But to Kepler, they were only incidental to his quest for a cosmic system based on the perfect solids, a system which, it turns out, existed only in his mind. Yet, from his work, we have found that scientific laws pervade all of nature, that the same rules apply on Earth as in the skies, that we can find a resonance, a harmony between the way we think and the way the world works. When he found that his long-cherished beliefs did not agree with the most precise observations, he accepted the uncomfortable facts. He preferred the hard truth to his dearest illusions. That is the heart of science.